of week 1 and 2, and whenever we'll do the questions, uh, you will get the idea what kind of questions has been already asked in the previous terms from week 1 and week 2. Okay, so we are live now. Give me a minute. I will share my screen and we will start the streaming. Okay? By the way, at 8 p.m., do you have any other session or is it the only session?
So one session going on by
Yes, sir. We have for math session.
Math.
math.
Okay, from 8 p.m. onwards.
Yes,
Okay, no
sir.
problem. We'll try to finish. Anyway, we have to discuss 2 weeks, so I think that we will cover. Okay. So can you see my screen?
Yes.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Yeah, great. Okay. So major concepts, from week 1 and week 2 are, you have seen already. We will start from the what is the joint probability mass function, right? In short, we are saying joint PMF. Next concept will be if you have joint, then how to calculate marginal PMF, right? If you have marginal, then if you have joint PMF and marginal, then how you can calculate the conditional PMF. I hope all of you are you can recall this kind of terminology and concepts. Yes or no?
Yes,
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 somewhat.
sir.
sir.
Yeah. Then next concept is independent random variables. Okay. And after independent, there is something called IID. So IID stands for independent and identically distributed. Yes or no?
Yes, sir.
So I'm hoping you are able to understand whatever I'm writing. And major concept from week 2 is called function of random variables. Okay, so functions of random variables, let's say you can define, let's say I'm defining z1 as I can define as x plus y. Yes or no? You can define z2 another new random variable as, let's say, x into y. Correct? Function is also you can define maximum of x comma y, and another function you can define minimum of x comma y. Okay, so these all things we will see. There is some background noise. So these all things we will see, and also I have a collection of questions which will cover, the questions from these topics. Okay. So first we will see joint PMF, right? So in stats 1, we have seen probability mass function for a single random variable, right? So there is two key property for being a valid PMF. First one, all the probability should be greater or equal to 0. Second one is summation of all the probabilities should be equal to 1. So this two key property is also applicable for joint probability mass function. Okay, so joint probability mass function means there will be two discrete random variables x and y, because PMF is we can define only for discrete random variable. Okay, so there will be two discrete random variable. Okay, and suppose the range of x means whatever the possible values random variable x can take is, let's say, tx, and for y, let's say it's ty. Okay, tx means it can take all the possible values for x, and ty is all the possible values for y. Okay, means random variable y can take. So how you can define the joint probability mass function fxy? Okay, so it can be, yes, yes, Kautilya.
So may I know the week-wise variables?
At the beginning of the session, I informed whatever the general doubts we have, we can discuss at the end of the session. Okay. So for week 1 to 4, you have to prepare anyway all 4 weeks. Okay.
Okay, sir. Thank you.
So suppose this joint PMF, I can denote as a, let's say, T1, comma T2. So this T1 is one of the values of random variable x. T2 is one of the values for random variable y. So how I can define this means x equal to T1 and y equal to T2. Okay. I hope this is clear to all of you. So T1 is belong in the this Tx and T2 will belong into Ty. Okay. So what is the key property? So by using this information, how you will check your joint PMF is valid? First one is, we write what are the properties. Okay, so first property is this joint probability should be in between 0 and 1. Would you agree with me?
Yes, sir.
And second,
Yes, sir.
x belongs to Tx means a summation for all the values of x and summation over all the values of y, right? So this should be equal to 1. Yes or no? Yes, Sanj?
Yes, sir.
Sir, are we able to access this PDF?
Yeah, once session will finish, then you can access, right?
Okay, sir.
So I'm requesting again with all of you, whatever the general doubts we have, we can discuss at the end of the session. Okay. I hope this is fine to all of you. Okay, so this is two key property to check the valid probability mass function for a for two random variable x and y. Okay, so let's say I have a joint probability mass function table that's called a joint PMF table. Okay, so suppose I'm saying let's say this is y and this is x. You can interchange this also, that's not a problem. This y you can write as a x and this x you can write as a y, that's not a problem. So key thing is we need to understand, okay, let's make it x and y itself. Okay. So here x is taking, let's say I'm saying 0, 1 and 2. Okay, suppose, and y is taking 0 and 1. So this just assume this is 1 by 6, 1 by 4. Okay, and suppose this is 1 by 6 and 1 by 8. Okay, and suppose this is 1 by 8 and 1 by 6. Okay, so my question is this a valid PMF or not? Can you check?
Yes.
Is this is valid?
Yes, it is.
It's valid.
Yes, sir.
How?
Yes,
Because you can add, so 1 by 6 plus 1 by 6, this 1 by 6. It's a total 3 by 6, 1 by 8, 1 by 8. So it's 1 by
Sir,
4,
actually,
right?
you have to calculate the marginal PMF and then check whether
Yeah, I
it's
will.
sums up
That's
to
okay.
1 or not.
One second. So let me go sequence wise. So we can go with the marginal. That's not a problem. So the key thing is I want to just check with these two property. That property you can check with the marginal also, since I haven't introduced marginal as of now. That's why I'm going with this part. Okay. So this you can cross check. So this 1 by 6, 1 by 6, 1 by 6, it will become 3 by 6. That is half, right? 1 by 8, 1 by 8
Yes, sir.
will become
1 by 4.
1 by 4, and this 1 by 4 again 2 by 4, which is half. So half plus
1
half,
by
this
2.
is 1.
1.
So 1, and we can see all the probabilities are greater than equal to 0. So this is valid joint PMF table, right?
Yes, sir.
Okay, so this concept is clear.
Sir, can you repeat?
See how you can check the joint probability mass function. All the entries should be between 0 and 1, and summation of all the probabilities should be equal to 1. So you can see all the entries are between 0 and 1, right? And if you will add all these entries, all this joint probability, you will get total sum as a 1. Okay, so that's why we can see this is we can say this is a joint probability mass function table. Okay.
Yes, sir. Thank
Okay, so
Yes, sir.
suppose yeah, let me introduce that. Someone says marginal. Okay, so how we can calculate actually marginal PMFs? Okay, so marginal PMF, suppose you have been given x and y, these two are, let's say, discrete random variables. Okay, and fxy, x comma y, this is joint PMF you have been given. Okay, now how you can calculate marginal? So marginal means I'm talking about PMF for of a individual random variable. Okay, so if I need marginal PMF for random variable x, then how I can calculate? I need to add for all the values of y this joint probability. Yes or no?
Yes,
And
sir.
if I
Yes, sir.
need the
Yes, sir.
marginal PMF for y, what I will do? I will add throughout the range of x this joint probability. Yes or no?
Yes, sir.
Correct?
Yes,
Yes,
sir.
sir.
So let's do this
Correct,
one.
sir.
Let's do this question. So it's 0, 1, 2, 1 by 6, 1 by 6, 1 by 8. Let me redraw that table. Suppose this is x, this is y. So this is 0, 1, 2, and here it's 0 and 1. 1 by 6, 1 by 6, 1 by 8, 1 by 4, 1 by 8, 1 by 6. Okay. So this is the case. Now, so I told you if I need joint PMF for x, right? Then what I have to do? I have to add for all the values of y. Suppose I need this. Okay, this will give you x of x. Yes or no? So this column, if you will add this column, it will give you marginal for x. Are you getting my point? Because these are the values for random variable x, right? And these
Yes,
values
sir.
for random variable y. Okay. So what? Okay. Suppose my question is what is fx of 0? So that means what? This means x is 0 is fixed, right? So I will add y equal to 0 and x equal to 0 plus probability y equal to 1 and x equal to 0. Yes or no?
Yes, sir.
Yes, sir.
This means what we have to do? We have to add this plus this, right? Are you getting my point?
Yes, sir.
So this will
Yes.
become
Yes.
Yes, sir.
what will be the value for this? 5 by
12.
5 by 12, right? If I need fx of 1, that means so. Okay, so you can check here x is taking value 1. So I'm interested only fx of 1, right? So fx of 1 means I need to add for the support of y. So we need to add this 1 by 6 plus 1 by 8. So this will become it's 7 by 24,
24.
right? If I need fx of 2, I need to add this 2 value, right? So it will
Yes,
become
sir.
again 7 by
24.
24.
7 by 24.
Now if you need fy, so this will become fy of 0. So that means I need to add this all the entries in this row. Are you getting?
Yes, sir.
Yes, sir.
So this will be 1 by 6 plus 1 by 6 plus 1 by 8. It's become
11 by 24.
11 by
11 by 24.
correct. And this value will become 13 by 24, right? So you
Yes,
can
sir.
check it's total
So
1.
1.
1.
okay. So you can see all the entries, I mean grand total is 1. Okay. So now you got the idea how to calculate this marginal PMF.
Yes, sir.
Yes, sir.
Yes.
Okay, one more thing. Suppose during the exam, suppose this 1 by 6 is not given to you, and instead of this, suppose some unknown quantity is given to you. Then will you able to calculate?
Yes,
Yes,
sir.
sir.
Yes, sir.
Suppose this is A, for example, and this is B. Then how will you proceed for B?
Sir,
You
B
can
will be 5 by 12 minus 1 by 6.
correct. And for A,
11 by 24 minus 1 by 6 minus 1 by 8.
Correct. Great. So this was 1 by 6 and this was, I think, how much? 1 by 4, right? Yes. Okay. So far it is fine. Some
Yes, sir.
Yes, sir.
now.
Yes.
So we have seen, so there is one thing. So if you have been given joint PMF, right? Do not worry about the questions, we will do. And then from the joint PMF, I can calculate the marginal PMF. If I'm able to calculate the marginal PMF, then I can calculate the conditional PMF. Would you agree
Yes,
with
sir.
me?
Yes, sir.
Yes, sir.
Right? So we will try to understand with an example. Okay. So suppose you have seen the conditional probability for two event. So what is the conditional probability formula for two event? Probability A given B. So probability of A
A intersection B divided
divided
by
by probability of B.
B.
So here intersection means I'm talking A and B divided by probability of B, right? This is the basic formula for conditional probability, right? Now, so
Yes,
what
sir.
we will do in conditional PMF, let's try to understand. Actually, formula is the same. In conditional PMF, so okay, here as B has been already given, right? We have information about B. So similarly, suppose I'm saying, given that capital X is taking one value, let's say small x, okay? Then my question is, what is the conditional distribution of, let's say, y? Are you getting? So what we have to calculate, basically, I'm asking what is the conditional distribution of y given that x equal to x? Yes or no?
Yes.
So
Yes,
this
sir.
means I can write this as a, okay, formal notation will be y given x equal to x, and here I'm interested in y, right? So how you can, what will be the formula for this by using the above information?
The joint y comma x,
So I can write, first of all,
probability of y comma
joint,
x.
okay, what is this? This I can write joint PMF
Yes, sir.
divided by,
Y
this is
marginal.
marginal, right? So what I can write in the numerator part?
P of y comma x.
P of y comma x.
P of, not, yeah, you can say. So I can write probability of y equal to y, x
Comma
equal
x
to
equal to
x,
x.
divided by probability of x equal to
X equal
x.
to x.
Is this clear?
Yes, sir.
So this means in the numerator part, okay, if you go with the formal notation, I can write fxy, x comma y, divided by fx of x. Yes or no?
Yes, sir.
Yes, sir.
So what is this? This is joint,
Joint
and this is,
marginal.
Marginal.
and
Marginal.
you know from the if you have been given, if you have been given the joint PMF, you can calculate the marginal, right?
Yes,
And
sir.
then you can calculate the
Conditional.
conditional probability formula. Yes or no?
Sir,
Yes, sir.
Yes.
sir, fxy equals to fyx that we already uh, proved in
Sorry.
the lectures.
Fx.
Joint PMF notation. Joint PMF notation we can write like fxy x comma y equals to fxy y comma x. Both will give same value, right?
You're talking about
When you are
fx,
writing probability
fxy
of,
or fyx, right?
yeah, fyx and fxy.
Yeah, the same thing.
Both
Yeah,
will give same value.
correct. So okay.
Okay.
Okay, what is this? This is x equal to 1 and y equal to 0.
Yes, sir.
If I will ask y equal to 0 and x equal to 1,
Yeah, it will be same. Correct. Yes,
correct?
got it.
Okay. Yeah. So
Yes.
whenever you are getting difficulty with the, some terminology, it's better to take one simple example. That will give you a clear idea. Okay. All right. Yes. No.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So
Yes,
from
yes,
here,
sir.
can you see? Okay. So if this is the case, right? So if you have been given joint and marginal, you can calculate the conditional. Okay. So one more thing we can interpret from here. If we have been given the conditional, suppose, okay, then I can calculate the joint PMF. Okay. What is this? This is conditional, right?
Yes, sir.
Yes, sir.
So it will be conditional
into marginal.
into marginal, right? I mean, you can simply think it as, you have three quantity. Out of three quantity, if one is unknown, you can calculate, sorry, two is known to us, one is unknown, then you can calculate that unknown quantity with the help of other two. Yes or no?
Yes, sir.
Yes, sir.
Right? This is the basic thing. Okay, if this is the case, can I do in reverse order? If I will ask what is the fx y given y x, then what will the numerator part? Again fx y, x comma y, and denominator will be y given to us, so
Margin of
it
y.
will be marginal
F
of
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 y
y,
y.
given y.
right?
Yes, sir.
Okay, is this clear?
Yes, sir.
Yes, sir.
Okay, great.
Yes, sir.
So let me take some one more example. Okay.
Excuse me, sir.
Yes.
Sir, I want to see that marginal PM, that page.
Okay.
Little bit more.
1 second. Yeah.
So a bit more up. Oh, yeah, this one.
What is query?
So nothing. I just wanted to take screenshot, and that table also.
Anyway, we will upload the PDF. Do not worry about these kind of things. Okay.
Okay, sir.
Yeah. Okay.
Thank you.
Let's do some another kind of question. Okay. Suppose I'm saying you have been given the joint probability mass function of two discrete random variable as fxy, x comma y. Suppose this is as you have been given, let's say 1 by 24 x into x plus y. Okay. And I'm saying range of x is, let's say 1 and 2, and range of y is, let's say 0, 1 and 2. Okay. And it will take value 0 otherwise. Okay. Suppose this is the case. So first, suppose my question is compute the or find the joint PMF table. Okay. Then how you can calculate? Okay. So first of all, let's make the table. This will be x, this will be y. So what is the range of x? 1 and 2. And for y, it's
0, 1, 2.
0, 1, 2. Okay. So how will you proceed? So basically what we have to do,
Sir,
we have
we
to
have
substitute the values for x and y, right? So for this part, for this entry, how will you calculate? So this means we have to substitute value of y as a 0 and
and
value of
x
x
equal to
as,
1.
right? So if you will put y equal to 0 and basically, okay, let me write like this. Suppose this means if I have to calculate probability x equal to 1 and y equal to 0, right? So if you'll substitute this value here, what you will get? 1 by 24, 1 into 1 plus 0. Yes or no?
Yes, sir.
You can see x, value of x is 1, 1 plus 0, right? So it will be 1
1
by
by
24.
20.
Yes,
And
sir.
this what will be this entry? I have to calculate, I have to put x as a 2 and y as a
0.
0.
0.
So what it will be? 2
So
into
1 by
2
6.
plus, yeah, 1 second, 2 into 2 plus 0 divided by 24. Let's make it
Yes.
4 by 24.
4 by 24. Yes.
Yes or no? Right?
Yes, sir.
Yeah, it will be 1 by 6. That's not a problem. What about this? This is 1. This is 1. So that means x will be 1, y will be 1. So 1 into 1 plus 1, that is 2 by
1 by
24.
4.
2 by 24.
Right? And now
Yes, sir.
we have to put x as a 2 and y as a 1. So it will be 2 into 2 plus 1. That is 3 into 2. 6 by 24.
6 by 24.
Correct? Everyone is
Correct,
getting
sir.
this point, how I'm making this PMF table?
Yes, sir.
Yes, sir.
Yes, sir.
Right? Okay. Now x is 1 and y is 2. So it will be 1 into 1 plus 2. That is 3 by
3
24.
by 24.
And for this is 2 and this is 2. It will be 2 plus 2 into 2, that is 8 by.
8 by 24.
So you can simply check addition of all the probability is equal to 1 or not,
Yes, sir.
right?
Yes, sir.
Now, if this is okay to you, suppose my question is, we will revise the concepts. If my question is, what is the probability x equal to 2? Or if I will say, what is fx of 2? That means what? I need to find the, okay, you will tell me how
Marginal PMF of 2.
marginal PMF of 2. Is this correct statement?
Marginal PMF of x equals
X equal to
2.
2.
Yeah.
Right? So this part will take f x of x, and this part will be f y of y. Okay. So that means what? We are okay. Basically, what is the meaning of this fx2? Means I have to add y equal to 0, x equal to 2, plus, I mean, basically you have to think when x is 2. So x is 2 for this part, or this part for this part, right? So y equal to 1, x equal to 2, plus probability y equal to 2, x equal to 2. Would you agree with me?
Yes, sir.
Yes, sir.
So that means what? We have
Yes,
to
sir.
add all these entries, right? So
Three
this will
values.
be 18 by,
24.
3 by 4.
is this clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
What if my question is fy of 1? That means what? My question is, what is the probability y will take
So
value?
marginal probability of y equal to 1.
Okay, so this means when y will take value 1, you have to think when y is taking value 1 for this row, right?
Yes, sir.
Correct. Whenever you have been
So
given
8 by
question,
24.
so whenever you have been given any question, just see. Suppose I will ask, so yeah, it will be 8 by 24. If I will ask, what is the fx of 1? Okay, so fx of 1 means when random variable, my random variable x will take value 1. So when x is taking value 1 for all the for this column, right?
6 by 24, sir.
So it will be 6 by 24. So now will you able to do the questions related to this part?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Now,
Yes, sir.
suppose I'm going to change the question. What is the probability that, let's say, y equal to 1 and x equal to 2? This means probability that y equal to 1 and x equal to 2 divide by probability that x equal to 2. Yes or no?
Yes, sir.
Yes, sir.
So what is the joint probability y equal to 1 and x equal to 2? This means this value,
3 by 20.
6 by 24.
right? This is y equal to 1 and x equal to 2. This is the joint probability,
Yes, sir.
correct?
Yes.
So numerator part is 6 by 24. And what about denominator part? Probability x equal to 2, which is
So 18 by
18 by
24.
24.
by 24.
So 24 will get cancel out. So you will
1
get
by
1 by.
3.
Okay.
Yes.
Are you getting the questions right, everyone?
Yes, sir.
Yes, sir.
Yes.
Now,
Yes.
let me change a bit more. Suppose, uh, what is the probability that y is greater than equal to 1 given that x is less than 2? This means, what will be the numerator part? Y is greater or equal to 1 and x is less than 2. Divide by probability that x is less than 2, right? So you have to think a bit here. Okay. So probability that y is greater or equal to 1, right? And x is less than 2 means what?
1.
There is only one value.
Sir,
X,
only one,
x,
sir.
correct? X is equal to 1. Divide by x is less than 2. Again, probability x equal to 1. Now you have to think for the numerator part. Okay. So numerator part is given as y is greater than equal to 1 and x equal to
Excuse me,
1.
sir.
Yes.
1 and
Can you repeat this greater one part again, please?
Yeah, this is the given to us, right? So this formula is okay. This conditional part I can write this as a joint divide by marginal. Yes or no?
Yes, sir.
Now, if since it is given to us x is less than 2, and we know from the table we have only two values, right? X is will take value either 1 or 2, right? X is less than 2 means x is equal to 1 only.
Yes, sir.
Correct? And numerator part is sorry, denominator part is again x is less than 2, that means x is equal to 1 only.
Yes, sir.
Fine.
So what if we have more than one entries, more than two entries?
Accordingly, you have to take the values. Okay. For example, suppose x is taking 0, 1, 2, right? And then it's x is less than 2. Then you have to consider x equal to 0 and x equal to 1 also. Okay.
And for
Whatever the
answer, we have
condition
to
will
add
satisfy.
that.
Sir,
Correct.
sir, one doubt, sir.
Hmm.
Sir, in case if we have x 0 also in the
Hmm.
denominator part, we are even going to multiply p of x equals 0 and p of x equals 1.
Not multiply. It will be probability of x equal to 0 plus probability of x equal to 1.
Okay.
Addition.
Addition, right? So you have to
Yes.
think. So my question is, suppose I'm saying x is less than 2. When x is less than 2, when that means what? X is either 0 or 1, right?
Yes, sir.
Okay. In the numerator part, if you see, what is the question? Y is greater or equal to 1 and x equal to 1. So what are the possible values? So when y
values.
is greater or equal to 1, this part and this
So
part,
5 by 20.
this means this is our interest, this is the part in which we are interested. Yes or no?
Joint.
Okay, let's break it. Numerator part, y is greater or equal to 1 means what? Y is equal to 1,
Of y
x equal to 1
x equal to 1.
plus y can take value 2 and x equal to 1. Everyone will be agree with me,
Yes, sir.
Yes, sir.
Yes, sir.
right? Now you have to find y equal to 1 and x equal to 1. Y equal to 1 and x equal to 1. This is
So 5
2
by
by
24.
2 by 24. So this will be 2 by 24 plus y equal to 2 and x equal to 1. So y equal to 2 and x equal to 1. This is 3 by 24. And what is the value for probability x equal to 1? This is 6 by 24, right? So this will be 6 by 24. So numerator part is 5 by 24. Denominator part is 6 by 24.
5
So
by
answer
6.
will be 5 by 6. Is this clear to everyone?
Yes, sir.
Yes, sir.
If sir, if it was x is less than equal to 2, then denominator has also two possibilities. So
Correct.
then what? How we should proceed?
Yeah, that's you will tell me. Okay, suppose I'm saying probability y greater than or equal to 1 and x is less or equal to 2, right? So this numerator part will be y greater or equal to 1 and x is less or equal to 2. Denominator is x is less or equal to 2, right?
Yes,
So what
sir.
is the possible values for numerator part?
Possible
Sir, y
value
equals 1,
Y
x
equal
equals
to 1.
x
Okay,
equal
y
1.
equal to 1, x equal to 1 plus probability y equal to 1
y equal
and
1
x equal to 2,
equal to
right? One second, let me rewrite again. So this means what? See here, y is greater than equal to 1 means what? Y can take value
1 and 2.
0, sorry, 1 and 2,
1 and 2.
So
and
1 and
x
2.
can take also 1 and 2, right?
1 and 2.
1
Yes.
and 2.
So basically, you have to think about all the cases. This means it will be
All the
like this.
combinations.
Correct.
4 cases.
Y
Huh.
equal to 1 and x equal to 1 plus y equal to 1, x equal to 2 plus y equal to 2, x equal to 1 plus y equal to 2, x equal to 2, and denominator part will be probability that x equal to 1 plus probability x equal to.
X equal to 2.
Oh,
Okay,
okay. Thank you,
got
sir.
it?
Yes.
Okay, great. Yeah. Now, so similarly, we can proceed for, if you have multiple random variables. Okay, multiple random variables means if you have more than 2 random variables. Okay, so
Sir, can you please explain this again?
which part?
So this one.
Yeah, so here you have to think what are the possible values y can take. So okay, what is the range of y? 0, 1 and 2, right? So greater
Yes,
or equal to 1 means y can take value 1 and 2. X is less or equal to 2 means x can take 1 or 2, right? So you have to think all possible combination. So y equal to 1 and x equal to 1, or y equal to 1, x equal to 2, right? You can see all the possible combinations. Okay, y is greater or equal to 1 and y.
Oh, yes, got it now.
Got it?
Yes,
Yeah.
sir.
Okay.
Thank you.
So similarly, we can proceed for multiple random variables also. So if you have two random variables, like for two random variables, multiple means more than two. So similarly, you can extend the part. Let's say you have been given this joint probability. I can write this part as a y given x equal to x into y fx of x. Yes or no? Conditional into marginal.
Yes, sir.
Right. Similarly, if you have three random variable, let's say f x y z, okay, and this x, okay, make sure this denotes the random variable, and these notations are you can say possible values for those random variables. Okay, so you can write this as a f x of x into f y given x equal to x y into f z given y equal to y x equal to x, and basically this will be z. Okay, so you can similarly extend the part. Okay, basically these two will give you the form of f y z given that x equal to x and y into small z. Would you agree with me? This x equal to x and this will be, you can multiply. I mean, basically you can write like this. Okay, so this is just a extension for uh, more than two random variables. Is this fine?
Yes, sir.
Okay, so let me give you one example and then we'll proceed for this three random variable also. So suppose I'm saying fx y z. Okay, this is given to you. Let's say 0 1 1 is the 1 by 10, and let's say fz of 1 is nothing but 2 by 5. Okay, and let me make sure x given z equal to 1, and let's say y equal to 1, and 0 is, let's say, 3 by 4. So question is, find f y given z equal to 1 of 1. Okay, so what is the meaning of this part, f y given z? Okay, let's write the solution part. Okay, everyone got this idea, yes or no? This part, this joint equal to marginal into conditional, yes or no? You
So
can
will
think, you
will
can
that
think.
be y
Yes,
comma
sir.
z or yz?
One second, you can think yeah, this is yg, right?
Uh, i- i- okay,
Yeah, y
multiplied
comma
or
g,
comma?
sorry, y comma g. Yeah,
Uh,
this is the joint for y and g. Okay,
yes.
so you can think like this. So whenever you had two random variables, you simply calculate marginal into conditional, right? Similarly, if you have three, so you can think marginal of x and conditional of other two. I mean, conditional that given that x equal to x and joint of other two. Yes or no? Got it? Yeah or not? Are you getting?
Yes, sir.
Okay. Okay. So what about this part? 0 1 1. Okay. How I can write whatever? Okay. Can I write this part as a, correct me? Can I write this as a fz of 1, because I have marginal of this part? Okay, you can interchange all these conditions. You can interchange this conditions part, marginal and all. Yes or no?
Yes, sir.
Yes, sir.
Correct. I mean, if you have been given fxy, okay, what do I mean by that? Let's say if I be given x equal to y, how will you proceed for this? Fx of y, x comma y divided by fy of y, right? The same thing if I want to write, okay, this part I can write. If I want marginal part, sorry, joint part, I can write this conditional into marginal in the reverse order. If suppose x is x equal to x is given to us, so numerator part will be marginal, sorry, joint divided by marginal. So from here you can see fxy, x comma y will be what? Fx of x into this conditional. Yes or no? So you can see, you can interchange, right? So similarly you can go for the three random variable. Let's say I'm saying f y z, x equal to x is given to us, y comma z, right? Then this will be f x y z, x comma y comma z divided by fx of x. Yes or no? Similarly, you can consider like
Yes,
this:
sir.
fxy given that z equal to z, fxz given that y equal to y. Are you getting? So you can interchange these values. Okay.
Yes.
Okay. Now let's solve the problem. Okay. So solution will be, so fxyz 0, 1, 1 is given to us. Okay. Which is 1 by 10. Okay. Let me rewrite the question itself. So fz1 is 2 by 5. Let me rewrite the question. Okay, so everyone is getting these ideas, right? How we can extending these values, right? 0, 1, 1 is 1 by 10, and fg1 was 2 by 5, and fx given z equal to 1, y equal to 1 was at 0 equal to 3 by 4. So you had to calculate fy given z equal to 1 of 1. Okay, so this you had to calculate. So solution will be basically, so we can proceed with this fxyz 0, 1, 1. So we have been given marginal of this, right? fz1. Now I need to calculate y given z equal to 1, 1. And then okay, what else we have been given? Can you identify? So we have calculated z part and y part. So can I write x given z equal to 1, y equal to 1? Would you agree with me?
Yes, sir. We
All
can
right.
multiply
Yeah.
these.
Correct. Correct. So what is this part? This is 1 by 10 and this is 2 by 5, and this part
Right.
we have to calculate, and this part we have been given as a 3 by 4. Okay. So from here you can
Excuse me,
calculate. Yes.
after this, we have to multiply this. Can you repeat this?
Which part?
The multiplicative part.
This part.
Yes, sir.
Okay. So what I would suggest you, just go with this. Just expand this part. Okay. Just apply the conditional probability formula on this part.
Yes.
Okay. You will get the idea. So you can see here, right? So you can interchange the values. Okay. If okay, for 2, suppose this is the case. I'm saying suppose y is given to us. Okay. And here you can see this joint probability same as this one or not. Right. So you can interchange this part and you can get the values. Okay. So here if you see the basic formula, then I told you right here for 3 random variables. So what I did for fx I took as a marginal, right? Then y given x equal to x for single condition of single random variable. Then you can see z given y equal to y. Now what I did there, we can do like this also. Basically, I did z of z. Okay. Now f y given, let's say z of z. Okay, then what will be the remaining part? Okay, okay, you can simply see what are the things we have calculated here, z and y. Yes or no? So remaining is x. Are you getting?
Yes, sir.
Yes, sir.
Okay. So okay, one more thing, what you can do, just take a pen and paper and apply the conditional probability formula on this. Okay. So this will become 2 by 5, and this is part something we have to calculate, and this is 3 by 4. Okay, so just solve this. I think this will get 2, and this will be 2. I think it will get cancelled out. It will be 2 will get cancelled out. So 1 by 3 is the correct answer. Okay, fine.
Yes, sir.
Okay. Is this all right? Okay, so you can simply actually this part. Okay, let me write this part. So this part was fx. Let me write in general. Suppose z is taking z, y is taking y. So this x, what I can write in the numerator part, it will become x equal to x, z equal to z, or y equal to y. Right? Denominator will be joint PDF of y and z. Right?
Yes, sir.
Yes or no? Now, what you can do?
Sir, PDF or PF?
PMF, I think.
Sorry, it's the PMF. Sorry. So it will be now fxyz xyz, right? You can write this as a fzy y comma z into fx given z equal to z, y equal to y. Yes or no?
Yes, sir.
Correct.
Yes.
Now, one more thing. If you have this joint, can I write this joint as a fy of y? Oh, sorry, fz of z. Okay, you can write f z of z into f y given z equal to z and y. Yes or no? Are you getting? Only this
Yes,
this
sir.
this joint. Yes or no?
Yes, sir.
Because of, if you have this conditional probability, okay, just think like this in reverse order. So you can write z comma y divided by probability. PMF of z, right? Now, if you'll multiply this, you will get this part. Yes or no?
Yes, sir.
Okay,
Sir, we
everyone
can
is getting.
also,
Hmm? Yeah, go ahead.
sir, there we can also consider that like Fy
Correct,
dot.
correct. That's not a problem.
Okay.
You can do reverse order also. Let's say I'm saying I can consider z given that y equal to y, I will get f y z y comma z divide by f y of y, right? Anyway,
Yes.
this okay. So from here, what if you see the numerator part? So I will get this as a f y of y into f z given y equal to y. Yes or no? I have just simply multiplied here, right? Got it?
Yes, sir.
Okay. So you can see this joint PMF is same as this joint PMF, right? So you can do in reverse order. Okay. All right. Yes. No.
Yes, sir.
Okay.
Yes, sir.
Oh, great.
Yes, sir.
So
Sir, we can break in direct denominator also, right?
Direct.
The original question.
Hmm.
So yes, it was given that. Okay. Okay. Sorry. I think I just made a mistake there. Okay. No problem.
Okay. 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 So next concept is independent random variables. Okay. Independence of random variables. Okay. One thing all of you know, and you have seen already, if you have been given two event, let's say A and B. Okay, if you have been given two events A and B, suppose these are two events, then how will you check the independence of these two events? Probability of A intersection B same as probability of A into probability of B, right? Or else can I say probability of A given B is same as probability of A, and probability of B given A is same as probability of B. Yes or no? So independence means happening or non-happening of other events doesn't affect the happening of another event, right? Correct.
Yes,
That
sir.
Yes.
is the meaning of independence, right? So this means what? Happening of B or non-happening of B doesn't affect the happening of event A, right? Similarly, happening of event A and non-happening of event B, happening of non-happening of event A doesn't affect the happening of event B.
Occurrence would be a better word.
Yes or no? So this is meaning of independence,
Yes,
right?
sir.
Okay. And the formula is this part. These all three are clear or not to all of you?
Yes, sir.
Sir,
Right?
Yes, sir.
The
second.
similar
Sir,
concept
can
we
you
will.
repeat second?
Yeah. So this
The
is
second.
concept of independence, right? So independence means what? Happening or non-happening. This is complement. Happening or non-happening of the event I mean second event doesn't affect the happening of the first event. Okay, that is the meaning of independence. Means there is no dependency. Means I'm saying, given that A is happening, given that A is not happening, this will not affect the happening of event B. Okay, this is the meaning of independence, right?
Got it.
You are not getting
Yeah.
affected by happening or non-happening of other events, right? Actually, this formula came from here only. So if you have been given probability of A given B as probability of A intersection B divided by probability of B, this is the formula of conditional probability. Can I write probability of A given B intersection B as a probability of A given B into probability of B? Yes or no? Basic mathematics, right? And we
Yes,
know
Yes,
sir.
sir.
when this is independence, this will be independence when probability of A given B is same as probability of A into probability of B. So this formula came from here actually.
Sir, it's very confusing. So can you repeat it again?
Which part is confusing?
Sir, here you write in the second line that PA slash B is equals to PA.
Hmm.
But in last you have written PAB, that is PA intersection B upon PB, which is so confusing.
This is the conditional probability formula. I'm just explaining how from where this formula came. Means I am saying A and B are independent if this is true. So when A, okay, so okay, this is the conditional probability formula or not? Forget about these
Yes,
three.
sir.
Okay, then if this is the conditional probability formula, then probability of A intersection B I can write as a probability of A given B into probability of B.
Yes, sir.
Just a basic mathematics here, right? And we know when A and independence means this should be true. So this A given B, this part A given B, I can write as a probability of A or not?
Yes, sir.
Okay, so from here the formula came, probability of A into probability of D. Got it? So if you are saying A and B are independent events, that means probability of A intersection B is same as probability of A into probability of B. Okay, means joint is equal to product of their marginals. Okay, so same concept we will apply if X and Y I have two discrete random variables, then if fx of y, x comma y is equal to product of their marginals. Okay, so this should be true for all x belongs to range of x and y belongs to range of y. Then I will say my x and y are independent random variables. Okay,
So in the previous slide, can you explain the complement part, like this the second line,
hmm.
like P of A given B complement is also P of A.
Yeah, so this is meaning of independence. Okay, independence means what? I'm saying, suppose you have two things, right? When you will say those two are independent, means happening or non-happening doesn't affect the happening of first event, right?
Okay, sir.
Right. So that, see, happening or non-happening. Suppose I'm saying probability of A given B, means whether B is. I'm saying what is the probability of A given that B is there happening. What is the probability of A B is not happening? Means complement. If this is equal to probability of A, that means it's independent, right? Means happening of A doesn't affected by the happening or non-happening of B, right? Understood?
Okay, sir. Got
Okay.
it.
The similar concept is there for random variables also. Okay. So here, what is this part basically? So this means probability x equal to x, and this is y equal to small y, and this is here x is taking value x and y is taking value y. So both are true. So this means what? Can I say this joint PMF, okay, is equal to the is equal to what? Product of their
Marginals.
marginals, right? Yes or no?
Yes, sir.
And
Yes, sir.
when you will say x and y are independent, I told you, right? Happening or non-happening doesn't affect the event of happening of first event. So that means what? I should say conditional PMF is same as marginal. Means fx y given y of y equal to, this should be what? You people will tell me.
F of x y.
Fx of y.
Marginal of
Just
x.
think a bit.
F of x y.
No, not y. I told you, right? A given B should be equal to probability of A, right? Only then you will say this is independent, right?
But you have taken the possible value of x as y, sir.
Sorry?
Yes,
But
sir.
you have taken the
Yeah,
possible
sorry,
random
sorry.
variable.
Yeah, yeah. Now is it okay?
Yes, sir.
Yeah,
Yes, sir.
that was by mistake. So this should be Fy of y, right?
Yes, sir.
Correct? Now, if I'm writing, there is one more thing. If fx of y, x comma y, is not equal to fx of x on and into f into of y, fy of y, even for some values of x and y, some values of y, then x and y are not independent. Okay. So basically, you have to check for all the possible combinations. Okay. So let's try to do. Okay, if this concept is okay, then there is one question related to this independence. So we will do there. Is this fine?
Yes, sir.
I have collection of
Yes,
questions.
sir.
We will do. Okay. Now next concept is IID. So what do you mean by IID? Anyone?
The marginal probability are the same and they are independent.
Independent and
Correct.
identically distributed.
Correct. So it's independent and identically distributed. Okay, that is full form of IID. Okay, so independent and identically distributed. So what do you mean by identically distributed? Means suppose you have two random variables, right? So those two random variables should be independent and uh, marginal should be same. Okay, let me write the definition. Maybe that will give you idea. Suppose I have x1, x2 up to xn. These are n random variables. Okay, suppose I'm saying these are n random variables. Okay, then they are said to be IID. Okay, if first part they are independent. Okay, so what do you mean by they are independent? Means fx1, x2 up to xn. Okay, x1, x2, xn. This is equal to what? Product of their
Individual.
marginals, right? This is meaning of independence. So far, so good.
Yes.
Right. Second is
Yes.
the marginal PMF. Marginal PMFs actually. That means fx of I means for each exercise. Marginal PMFs for each exercise are identical. What do you mean by identical? Anyone? It should be
Equal.
same.
It should be same.
Same.
So okay, this means what? Marginal PMF of x1, this is same as marginal PMF of x2, this is same as up to marginal PMF of x1. So actually, this is the meaning of uh, IID random variable. Okay, okay, the concept is clear. Okay.
Yes, sir.
Okay. For example, suppose I'm saying I have n random variable x1, x2 up to let's say xn. Okay. These all are, I'm saying IID. Let's say Bernoulli all are Bernoulli distributed with probability. Let's say for example 1/3. Okay. Then what is the meaning of here IID? This means joint probabilities for all means x1, x2 up to xn, all the values taken by each exercise. This is same as fx of fx2 of x2 up to product of fx1 of xn. Yes or no?
Yes, sir.
This means what? What is the fx of x1?
1/3.
Basically, yeah, 1/3 and all, right? So you can calculate the marginals, right? And second property. So say what? So this means identical means this means x1 is all also follows Bernoulli 1/3. X2 follows Bernoulli 1/3, right? Yes or no? Are you getting?
Yes, sir. Yes, sir. Yes, sir.
Okay. Yeah.
So, sir, the above thing that will be fx of x whole to the power n, where x is
Yeah,
our
correct. Because
1/3.
all are identical. Yeah,
Identical
correct.
and independent.
Correct.
So the independence give us a product, and identical will give us that.
Yeah.
Each will be same.
Basically, you will get fx of x whole
to the power
n. Yeah.
To the power n.
Okay. So regarding
Can be a
independence,
one example of IID.
yeah, anything you can take. You can take all x's are geometric, all x's are Poisson, or anything, right? If you have been given any table or something like that, okay, rather than any standard distribution, so you need to check whether these all x's are in the. I mean, whether first of all you need to check this whether product joint is equal to product of their marginals or not. Second is you need to check whether all sorry marginals of all x's are same or not. So means suppose let me give you the idea behind this. Okay, let me take one more table. Okay, we are running a bit delay. Okay, suppose there is one more example. Okay, so suppose this is 0, 1, 2. Okay, let me take very small table, not big table. Okay, let me take a small one. Okay, let me take very small value. So x, y. Okay, suppose this is x is taking value 0, 1, 0, and 1. So suppose all entries are 1/4, 1/4, 1/4. Okay, so what you have to do, first of all, you need to check the independence property, right? So to check the independence property, what you have to need to check? This should be equal to fx of 0 into fy of 0. Yes or no?
Yes, sir.
So okay, just calculate what is fx of x here. This will be 1/2, 1/2, 1/2, 1/2. Okay, this is fy of y. So you need to check all the entries. So what is the fx of 0, fy of 0? 1/2 into 1/2, which is 1/4, which is same as this part. Yes or no? If I will write fx of y 0, 1, this means what? Yeah, tell me, what should I write?
1/4.
fx of 0 into fy of 1.
fy of 1.
Correct?
Fy of 1.
So this, what is the fx of 0? 1/2 into fy of 1 is 1/2, which is 1/4, which is same as this part, right?
Yes,
Are you
sir.
getting? Then
Yes.
fxy, no, sorry, which is equal to this part because y is equal to 1, right? Fx of y 1, 0, which is 1/4. So you can, that means fx of 1 into fy of 0. So fx of 1 is half. This is 1/4. Correct? Then fx of y 1, 1, which is fx of 1 into fy of 1, which is again half into half, which is 1 by 4. So you can see we have checked for all the values. So joint is equal to product of marginals. That's why this is independent. And you can see all the marginals are equal to same, right? Yes or no?
Yes, sir.
So that's why this is identical as well.
Yes.
Will you say this is this is independent or not?
Independent.
Yes, sir, it is independent.
Sorry, this is
Sir,
IID or
you
not?
have checked only one property.
Which property? I checked both properties. Which property I'm missing? Can you correct me?
All marginal should be same.
So you can check all marginals are same or not. These are the marginals I have calculated, right? You can check whether fx0 is same as fy of 0, right?
Sorry, sir.
Then fx of 1 is same as fy of 1, right? Are you getting? So this will
Yes,
be,
sir.
this is identical. Okay. So one more thing, if any of the values in your table entry is if any one of the entry is 0, right? That will not be independent. You can cross check. Okay. For example, suppose this is 0. And for example, this is half. Okay. Now this is valid PMF or not? Right?
Sir, that fx of x should be 1 by 4, sir. It should not be 1 by 2.
Yeah, that I will change. I'm just giving you one idea. If one of the entries in your joint PMF table is 0, then x and y will not be independent. Okay?
It's a valid PMF table, but it's not independent.
Yeah, if any of the entries is 0.
Yes.
Okay?
Sir.
Got it? Yes? No?
Yes, sir.
Sir, one question, sir.
Hmm?
So suppose the range of x is from 0 to 2.
Hmm?
Then in that case, will it be independent because we will not have value for y in that case?
Sorry?
So if we have range of x from 0 to 2,
Hmm?
will it be identical in that case?
Yeah, it will depend on the values, right? Okay.
For marginal of 2, we don't have this f of y of 2.
Hmm?
So how do we
Actually, one second. You can go with the same thing, okay? First of all. Same thing means, let's say 0, 1, 2, 0, 1, 2. So all the marginals should be equal to same as the marginals of others. Okay, it should be same. Only then you can say identical. If one of the values is going to be different, you can't say this is identical. Okay. Yeah. So
Sir, for IID, should I check for f of x is equals fx of 0 is equals to fy of 0? Is that more important? Or should I check that they are actually following the same distribution? Because they might be following different distribution.
see, if you are following the same any standard distribution, right? Then you can say it's IID, right? For example, I took this example, right? I'm saying I simply told all exercises following Bernoulli, right?
Yeah.
Right. So I'm saying that means x1 is follows Bernoulli, and PMF will be same x for x2 for x3. If I'm saying let's say all exercises are following Poisson distribution with parameter, let's say 2. Okay, lambda is 2. Then again it's IID, right? Because marginals will be same. For each xi, you are going to get the same PMF.
Yeah.
All right.
Yes. Okay.
Okay. Yeah. So let me take another. Okay. So far so good, right? You got the some rough idea. You are getting. I mean, your concept is going to brush up or not? Yes.
Yes.
Yeah. Yes, sir. So next part is function of random variables. Okay. We will see some examples and then we will try to do the questions. Okay. Because function can be anything, right? So it can be x plus y, it can be mod of x minus y, it can be mod of x plus mod of y, it can be maximum of anything. So it can be anything. We will see. So function of random variables x and y. Okay. So for this part, we are considering like x and y as independent. Okay. And suppose I have given the information x follows, let's say I'm saying binomial. Okay. Then x follows binomial, or let me take any other which is simplest one. Yeah, let's take binomial itself. Let's say 3 comma 1 by 3. Okay, I'm saying y it follows, let's say Bernoulli 1 comma 4. Okay, so this information is given to you, for example. Okay, and you know x and y are independent. This is given to us. Okay, these two information we have. So my question is, suppose I'm going to give you the define a function. Let's say I'm saying I'm going to define z1, which is let's say x plus y, for example. Okay, if I'm saying, yeah, then my question is, you have to find the PMF of z1, that is f z1 of z1, right? This is small z1 you can consider. Okay, first of all, you will people tell me what is the range of x?
1 by 3 to 3.
Range of
0, 1, 2, 3.
0, 1, 2.
0 to 3.
correct. Range of y
0, 1.
0 and 1, because this is the Bernoulli only, correct? Now if x is this
So how do
0,
we get the range of x as 0, 1 to 3?
what is the range of binomial? Yeah, tell me. Don't worry about whether it's wrong or correct. We will correct it. What is the range of binomial? How will you define the binomial?
N comma p, I only know that.
Sorry?
N comma p, I only that.
N and p, that's okay. What is n?
Number of trials.
So number of trials, then what is the range of x? X can take any value 0 up to n, right?
Yes, sir.
So instead of n, what we have?
3.
Got it?
Yes, sir, I got it.
Now. Okay, so okay, what will the probability of x equal to 0 here?
P30 times 1
Okay,
by
okay.
2 by
First of
3
all,
to the power.
okay, one more thing. What is the PMF of x? What is the PMF of x? This will be in general NCX, right?
yeah,
P raised power x 1 minus P raised power n minus x. Okay. Now what we have, instead of n, we have 3 CX. P we have, I think 1 by 3 raised power x, and 1 minus 1 by 3, that means 2 by 3.
2 by 3.
Right? So 2 by 3 raised power 3
N minus.
minus x. So for probability x equal to 0, what it will be?
2 by 3 raised to 3.
So probability x equal to 0 means 3c 0, 1 by 3 raised power 0, 2 by 3 by raised power 3, right? So 3c 0 is what? 1. So
Yes,
basically
sir.
it will become 2 by 3 raised power 3, that is 8 by 27.
7.
So for probability x equal to 0, it will be 8 by 27. Similarly, what about probability x equal to 1? Just substitute all these values and tell me what will be the answer.
Four
All
by
of you have
9.
Yeah, 4 by 9.
4 by
4 by
9.
9. I'm believing on
Yes.
on the calculation. Okay.
3
What about
into 1 by 3 into 4 by 9. So 3 and 1 by 3 cancelled and 4 by 9 only.
for x equal to 2?
X equal to 2.
That will be the same. No,
No,
not same.
no. It can't be same. Can you check? It will be 3c2.
It will be 2 by 27, I guess.
2 by 2. Just calculate correctly, right? I'm not calculating
6
so
by
that
27. It is 6 by 27.
6 by 6 by 27. So 3c2, 1 by 3 raised
3c2
power
is 3, 1 by
6 by 27.
6 by 27. That means I can write as a 2 by 9, right? Yes or no? Right?
Yes.
Okay, so this is 6 by 27 and this is 12 by 27, right?
Yeah.
So 12 by 20 and 6, 26, that means this will become 1 by 27.
Yes, sir.
You can cross check, right? So this is PMF for X. And what is the for Y? So Y is taking value 0 and 1. So what is the, it will become 1 by 3 and, no. Yeah, 1 by 4, right? It will
1 by
become
1 by
1 by
4.
4 and 3 by 4, right?
2 by
Yes.
4.
So this information we have, okay? So what you can observe here, first of all, you have to calculate the PMF, right? The valid PMF, right? About your X
So
and
for Y it will be 3 by 4, and for 0 it will be 3 by 4, and for
oh yeah, correct. Yeah, thanks. Yeah. Because this is the success probability. Yeah, thank you. Yeah, this is the success probability, right? So it's 8 by 27. This is 4 by 9. This is 2 by 9. This is 1 by 27. Okay. This is PMF for X. And for Y, we have 0 and 1. So probability Y equal to Y. It's 3 by 4 and 1 by 4. Okay. So PMF of Y and X is clear to all of you?
Yes, sir.
Okay, great. So what we have to do, actually, what you can observe. So one suggestion, it might be like some, I mean, little bit, it may take some long time, but good thing is make table whenever you have been given the questions related to function of random variables. So what do you mean by table? So what is the possible values X can take here? 0, 1, 2, 3. Y can take 0 and 1. So my question is X plus Y, right? This is something we have to calculate. Yes or no?
Yes, sir.
All right. So what is the possible values of X can take here? In the question, it has been given 0, 1, 2, and 3. Okay, so try to find the all the possible combination. Okay. Okay. Let me write. Let me write. Okay. So 0, 0, 0, 1. I can write
Yes, sir.
1 because
1,
Y
0.
can take value these two value 1, 0, 1, 1. Then
2,
2,
0.
2, 1. Then
3, 0. 3, 1.
0, 3, 1.
I think that this is the possible combinations. If you
Yes,
will do during your examination, it may some second more, but thing is that you will get the correct answer if you rather than doing blindly. Okay, because so what is the possible value of X plus Y? It will be 0. X plus Y 1, 1, 2, 2, 2 plus 0 is 2, 2 plus 1 is 3, 3 plus 0 is 3, 3 plus 1 is 4. Now you can get the idea from here. So what is the possible value your Z1 will take now?
0, 1, 2, 3, 4.
So Z1 can take 0, 1, 2, 3, 4, right? But we have to calculate the, let's say, values. Okay. So what is the probability for Z? Sorry, Z1 will take value 0. So basically, what you have to do? What is the probability when X is taking value 0? It's 8 by 27.
8 by 27 into 3 by 4.
Correct. So basically, you have to calculate this part, fxy. And we have been given information, these two are independent, right? So
Yes.
it will be 8 by 27. And what is the y will take value 0, which is 3 by
4.
4, right? Now,
yes.
Are you getting? And X is taking 0 and Y is taking 1. So that means it will be 8 by 27 into Y is taking value 1, that is 1 by 4.
Yes, sir.
Correct? X is taking value 1 and Y is taking value 0. So when X will take value 1, is 4 by 9. So 4 by 9 into Y is taking value 0, that is 3 by 4.
Yes, sir.
X is taking value 1 and Y is taking value 1. So that is 4 by 9 into 1 by 4.
Yes, sir.
Everyone is getting right? And so
Yes.
on. X is taking value 3, Y is taking value 1. So what is the probability X is taking value 3? It's
1 by 27.
1 by 27.
So 1 by 27 into 1 by
1
4.
by 3.
So now if you will ask what is the PMF of Z1, okay. So for Z1, what is the possible value? It's taking 0, 1, 2, 3, 4. So what will the probability Z1 equal to take value some Z1? So you can see 0 is occurring how many times? Only one times, right? So
Yes.
this is the value. Okay, whatever the value will be. So it will be 3, 9,
6 by 20.
4, 2.
6 by
No,
9.
no. It's 2 by 9, right?
2 by
Correct?
9. Yes, sir.
Yes, sir,
So
2 by
for 0, it's a 2 by 9. For 1, you have to be careful. So for 1, we have to add these two value, right? Because 1 is taking Z1 is possible. Z1 will take value 1 in this case or in this case, right? So we have to add these two probability. Are you getting?
Yes, sir.
And for Z equal to 2, we have to add this probability and this probability. For Z equal to 3, we have to add these two probability. And for Z equal to 4, this will be 1 by 27 into 1 by 4. Is this clear to everyone? How to proceed with this?
Yes.
Sir, so is it like it is assured that this Z will form a valid PMF?
Correct. You can cross check.
Like every time it will form valid PMF?
Yeah, because X and Y is already valid, right? The
Okay.
key thing, you shouldn't make the mistake. That's all.
Okay,
Right?
okay. And what will happen if these two variables are not independent?
No, then you cannot multiply this probability, right? That is the different thing. For now, in stats 2, we are proceeding with this only. Okay. We will discuss that later, but I think we can focus there. Okay.
Sir.
Is this clear, right? This part. So for 1, you should do not take only this value. For 1, there is 2 times 1, right? So we have to add these two value. Everyone is getting this part, right?
Yes, sir.
All right. Yes. No.
Yes, sir.
Okay. Let's
Yes.
make another. Let's take another function. Let's say I'm saying Z2 is defined as X into Y. Okay. Then how to proceed? So what you will do? Again, the same suggestions. Write the X and Y. What are the possible values? 0, 0, 0, 1. Right? Then, yeah, tell me. You can speak. That's not a problem.
2021 3031.
Right?
Yes.
No. So my function is what? Z2 is what? X into Y. So we have to multiply all these values, right? So if you multiply, you will get 0 into 0, 0, 0, 0,
1,
1,
0,
0,
2,
2,
0, and 3.
0, 3. Now, what is the possible values Z2 will take? 0,
2, 3.
1, 2, 3, right? Now, what will the probability for Z2? So you can see Z2 equal to, let's say, small Z2, something like this. So you can simply see when X is 0 and Y is 0 is what? It was, I think, 8 by 27 into 3 by 4, right? Sorry, right? It's 8 by 27 into 3 by 4. Then again, okay, so X is 0 with probability 8 by 27 and Y is equal to 1 with probability 1 by 4. X equal to 1 with probability 4 by 9 and Y equal to 0, it's 3 by, both are 1. So 4 by 9 into 1 by 4. So I'm writing the probabilities from here, right? So
Yes,
X is,
sir.
for X equal to 1, probability is 4 by 9. For Y equal to 1, probability is 1 by 4 from here. So for X equal to 2, probability is 2 by 9.
Yes,
And Y equal to 0 is 3 by 4. Then 2 by 9 into it's
1 by 4.
1 by 4. And for 3, it's 1 by 27. It will be 1 by 27 into 3 by 4. And again 1 by 27 into 1 by 4. Everyone is getting this part?
Yes, sir.
So what is the probability for Z equal to 0? Z equal, that means what? When you have Z equal to 0? Here,
Are you
here,
repeating the question?
here and here. No, I have changed the function of random. Okay. It's X into Y now, not X plus Y. Okay. So here you can see we got the value. I mean,
One
this,
more zero.
30 is
oh,
also
sorry,
there.
50, right?
Yeah.
So what you have to do, basically, whatever the values of this will be, let's say this is For example, this is A1, A2, A3. This is A4. This is A5. I mean,
Sum it up.
after multi. Yeah. So addition of all this means addition of I equal to 1 to 5 AI will give you the value of 0. Right? Is this clear? How am I writing? You can see for x equal to 1, sorry, z equal to 1, there is only one value, right? So this will be 1 by 9, right? Yes or no? So this will become 1 by 9. For 2, we have only 1, which is 1 by, sorry, 2 by, or you can say 1 by 18. Yes or no?
Yes, sir.
Correct? And for 3, again, we have only 1, which is 27 into 4. You can multiply 20.
1 by 1.
27 into 4, what will be the answer? 4, I mean,
108. 108.
108, right? Yeah.
108.
So 108. So this will give you this summation AI. You have to calculate all these green parts. Okay. Is this clear to all of you?
Yes.
Yes, sir.
Okay. How you can calculate the function and all? Yes or no?
Sir, could you please explain that probability of 0?
So probability of 0, this part, this red part or green part?
Green one.
So you can see when Z2 is, okay, what is the unique value Z2 can take? 0, 1, 2 and 3, right? From this column you can observe, right? Okay. So now I'm saying Z2 will take value 0. So that means what? We have to add all this probability.
Yeah, okay.
Correct?
Yes.
Got it?
Yes. All the 5 values, yeah.
Correct.
Got it. Thank you.
Now we will proceed with one more thing, which is called maximum. Okay. Let's say I'm saying I have another function called Z3, which is, let's say, I have defined as a maximum of x comma y. Okay. So now again the same thing. If you will make the table, right, then there is very less probability to make mistakes. Okay, because you will get all these possible values. So suppose what is the possible values? 0 0 0 1 1 0
1 0
1 1 2 0 2 1 3 0 3 1, right? Now what is the function? Function says you have to take the maximum of x comma y. Yes or no? What is the maximum of 0 comma 0?
0.
Maximum of 0 comma 1?
1.
Maximum of 1 comma 0? Maximum of 1 comma 1?
1.
Maximum of 2 comma 0?
2.
2
Maximum of 2 comma 1?
2.
2
Maximum of 3 comma 0?
3.
3.
Maximum of 3
3
comma 1? 3. Right? Now, what is the possible value Z3 can take here? 0, 1, 2, and 3. Right? Yes or no?
Yes, sir.
Now, if I want to ask what is the PZ3 equal to, let's say, small z3, then what you have to do? For this part, you have to calculate when x is taking value 0 and y is taking value 0. That means if I can recall correctly, it should be 8 by 27 into
3 by 4.
3 by 4.
Yes, sir.
For this part, 8 by 27 into 1 by 4 and 4 by 9 into
3 by 4.
3 by 4, because y can take 0 with probability, and this will become 4 by 9 into 1 by 4, and this will become 2 by 9, right? Can you cross check? 3 by 4, 2 by 9 into 1 by 4, and this will become 1 by 27 into 3 by 4 and 1 by 27 into 1 by 4. Okay.
Yeah.
So if I will ask what is the probability that basically FZ3. Okay. So for 0, we have only one possibility, right? Let's make
sorry. 1
let's make
possibility.
it A1. So what it will be? It will be A1. For 1, we need to add all this probability, all these 3, right? That means suppose this is B1, value is B2, this is B3, addition of all these 3, right?
Yes, sir.
So this will become B1 plus B2 plus B3. Okay. When x is taking value 2, we have to add these two value, right? Let's say this is C1 and C2. So it will become C1 plus C2. I am not calculating this value, you have to basically do the simple multiplication part. And for, let's say, some another color, so for 3 we have to add this part, let's say d1 d2, so we need to d1 plus d2, so this will give you the PMF for function when maximum of x comma y. Is this clear?
Yes, sir.
Yes, sir.
Yes.
Okay. So similarly, you can proceed for minimum, right? If question is minimum of x comma y, then it will be 0, 0, 0, 1, 0, 1, 0, 1, right?
Yes, sir.
Are you getting my point? Right. One more thing, if I will ask, what is the probability that J3 equal to 1? That means what?
C1, B1 plus B2 plus B3.
B1 plus B2 plus B3, you can tell me. For example, suppose this is not given to us. That means what? I can say, I will say maximum of x comma y is equal to 1.
Yes, sir.
Right? So maximum of x comma y is equal to 1. Then again, I mean, basically you have to consider all these three cases. Okay? Understood?
Yes, sir.
Is this fine to all of you?
Yes.
Okay. Okay. Suppose there is a change. Change means, suppose instead of initially I asked x plus y, right? So this at this place you did x plus y. Suppose what if I will ask x minus y? Then basically you have to subtract the values, right? But the probabilities you have to multiply. Clear?
Yes, sir.
Okay. 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 So far you got the concepts, because I think I have covered more or less every concept of week 1 and 2 major concepts.
Yes, sir.
Clear?
Also, there were some graphs of maximum and minimum which were a little bit difficult to interpret.
Okay. Do not worry about the graph and all. We can discuss that later. Okay. So today's session is agenda for today's session just to cover up the major concept. Okay. Do not worry about the graphs. Okay. Yeah. Someone has raised hand. Yes. You have any query? Okay. So if all these things are clear to all of you, so function can be changed, right? It can be mod of x, mod of y, something like that, right? So all of you have pen and paper?
Yes, sir.
Okay, so should we start the questions which has been already asked in some previous terms and all?
Yes.
Yes, sir.
Okay, one more thing before going to start the what to say, questions. If you have been given maximum, right, then always try to convert into less than or equal to part. Okay, what I mean by that, because that will give you that will make the calculation easy. What I mean, suppose, let me give the idea, then I will start the question. Okay, so suppose I'm saying I have, let's say, x1 x2, these two are, let's say, I'm just taking two randomly for I, let's say these are some IID x follows some distribution. Okay, suppose I have defined z as a maximum of x1 comma x2. Okay, then it would be great to start maximum of x1 comma okay, let me do like this. If I will say probability that, let's say, z greater than small z, for example, okay, then it is always good to start with 1 minus probability z less or equal to z in case of maximum. Why? I will tell you. So okay, first of all, let's do for this, let's calculate this part only. So probability z less or equal to z will be what? This means what? Probability that maximum of x1 comma x2 is less or equal to z. Yes or no?
Yes, sir.
Okay, so if maximum is x1 or x2 less or equal to z, then can I say x1 is less or equal to z and x2 is less or equal to z or not? For example, suppose I'm saying
yes,
2 comma 3 is less or equal to 3. Then I can say 2 is less or equal to 3 and 3 is less or equal to 3, right?
Yes, sir.
But if we'll do in reverse order, then it would be difficult, right?
Yeah.
Yes.
And since these x1, x2 are IID, then I can say probability x1 is less or equal to z into probability of x2 is less or equal to z. Correct?
Yes, sir.
Now, since these are IID, then I can say x1 is less or equal to z just for 2 or not, because PMF will be same. Correct? Then simply you can substitute this value 1 minus probability x1 less or equal to z whole square. Got it? So whenever maximum is given to you and you have been asked this kind of question, then always good to convert in less than or equal to sign. Okay?
Yes, yes, thank you.
If you have been given the minimum, let's say some z star is given as, let me make it z1, minimum of x comma y. No, week 0 is not in quiz 1, okay? But week 0 concept, I mean, anyways, those are the just recap of stats 1. Suppose question is probability z1 is less than or equal to minimum of x comma y, okay? Or let's say less than only, for example, then it is, no. Let's say z1 is less than some small value z. Then it is always good to start with 1 minus z1 greater than z. Okay? Why? Again, the same twist. If minimum is given to you, it is always good to, because I can separate the terminology. Let's say, let's try to check. So it is minimum of x comma y is greater or equal to z, right? If minimum of 2 comma 3 is greater or equal to 3, 2, can I say 2 is greater or equal to 2 and 3 is greater or equal to 2 or not?
Yes, sir.
So if this is the case, I can separate x is greater or equal to z and y is greater or equal to z, right? Then since these are IID, I can say product. And similarly, since these are IID, then I will say this is as x is greater or equal to z, PMF will be same, it will be square. So I can do 1 minus this part. Yes or no? 1 minus star. Clear?
Yeah.
So
Yes.
just keep this in mind, just for just a smart approach for this, right? So here actually I took in general here your x can be anything. It can be, let's say x1 x2 is geometric 1/3, right? Then what you have to do?
Probability calculation will change.
Correct, correct.
But the concept remains the same.
Concept remain the same. So here x is, let's say I'm saying geometric 1/3, for example. Then what you have to do? Here it will become geometric 1/3. That means let's say x1 is less or equal to some 2. So you have to add values till 2. Are you getting what I mean? Suppose I'm saying x1, x2, let's say follows IID. Let's say I'm saying, just for simplification, let's say Bernoulli half. Okay. And my question is, let's say z has been defined as a maximum of x1 comma x2. And let's say I'm saying, what is the probability that z is, let's say it's, let's make it some binomial. Okay. For example, this is binomial. Okay. And the question is, z is less or equal to 2 or less than or equal to 1. This means what? Probability that maximum of x1 comma x2 less or equal to 1. Since these are less or equal to 1 and maximum, I can write x1 is less or equal to 1 and x2 is less or equal to 1. Since these two are IID, I can write x1 is less or equal to 1 into probability that x2 is less or equal to 1. Yes or no?
Yes.
If this is the IID, this will be same. X1 is less or
Sir,
equal
this, excuse me, sir, this PZ greater than or equal to 1 is given in the question.
Yeah, it will be given in the question. I'm just taking one random example. So what do we mean by here? This means you have to add x1 equal to 0 plus probability x1 equal to 1 whole square, right? So here you have to substitute the PMF of binomial, and given to you, right? So it's, let's say binomial, it's 3 comma half, something like that. Okay. Then you have to substitute the values here. Got it?
Yes, yes.
Clear the idea, right?
Yes.
Okay, great. Then let's try to move the questions and we'll try to do, I think at 8 you have session for mathematics, right?
Yes.
Okay, no problem. Let's try to do how many questions, whatever the question we will do. Rest question we can proceed in next session. Okay. Okay, since we are discussing this maximum part, let's try to do the maximum question one, maximum part one. Okay. Okay. Suppose this is a question. Okay, do not see the, this is the question. This is, you can say this is important. This kind of question. Okay. Now, so question is, a fair die is thrown 2 times independently. Here you can say independent, information about independence is given to us. Let x1 represent the number obtained in the first throw, x2 represent the number obtained in the second throw. Okay, this information is clear. Yes. No?
Yes, sir.
Yes, sir.
Okay. Now question is, I mean, there is one random variable z has been defined as a maximum of x1 comma x2, right? So question says find the value of z less or equal to 3. So this means what? Okay, what are the possible values? X1 represents number obtained on the first throw. Okay, so question number is 11. So x1 is defined as the number obtained on first throw.
Both ranges are 1 to 6.
X2 is number obtained on second throw. Okay, so you can see ranges are 0 to 6, right? Because it's the die. So 0, 1 up to 6. No, sorry, 1 up to 6 and 1 up to 6, right? Since z is defined as maximum of x1 comma x2, and one information given to us, this is independent, right? So question is, first question, what is the probability that z is less than or equal to 3? Correct? So this means what? This means basically probability that maximum of x1 comma x2 is less or equal to 3. Yes, no?
Yes,
are you getting my point, right?
Yes, yes.
So, okay, first of all, what is the possible values? Because we are interested in the outcome on both dice. So total outcome will be 36.
Yes, sir.
Yes or no?
Hmm.
Now, we have to just think in what cases maximum of x1 comma x2 will be less or equal to 3. So just think 1 comma 1.
1 comma 1 and
Then 1
1
comma 2,
comma 2.
because maximum of these two is less or equal to 3 or not? Maximum of these two is less or equal to 3 or not?
1 comma 3.
1 comma 3
and 2 comma 3.
2 comma 1,
Oh
2
yeah.
comma 2,
2 comma 3.
2 comma 3. Everyone is
sir,
getting, right?
1 comma 3. How is 1 comma 3? Sir, 1 plus 3 equals to 4.
It is max, not sum.
No, we didn't take the plus. It's the maximum of x1 comma x2, right? So maximum of, what is the maximum of 1 comma 3? 3, right? So 3, I can say 3 is less or equal to 3 or not.
Okay, sir.
Got it? We
Sir,
have to
but
think.
why are we taking these small cases? We know how to do it directly only. You just
What do you
showed
mean?
us.
Huh?
We could just write it. The probability will be what? Probability of x1 less than equal to 3 whole squared.
Yeah, that we can do. That's not a problem. Just trying to do in both way. Okay, it's
Oh,
not
okay.
like that is wrong. This is okay. I'm not saying. Okay, suppose you don't know that approach, direct approach. Then how to do in other way? That's also possible. Okay.
Okay.
I hope. Okay. So maximum of 3 comma 1 is also 3. Maximum of 3 comma 2 is also 3. Maximum of 3 comma 3 is also 3. Right? I think this is the possible cases.
Yes.
Or anything else? No. Right? So there are two approach. So what is the total cases here? 9, right? So probability of this is the favorable cases, and total cases is 36, which is 1 by 4. Are you getting? So that's the probability, right? This is the favorable cases. Yes or no?
Yes, sir.
Yes, sir.
Right? And total case is 36. See, to satisfy this condition, this is the numerator part, and to denominator we know out of these,
Excuse me, sir.
out of total 36, these are the possible outcomes. Yes or no?
Yes, sir.
Sir,
Yes.
these two random variables are independent.
Yes.
So how can we their outcomes in total?
No. If you you didn't read the question carefully, then what is the question? We are throwing die 2 times, okay, if you are throwing die 2 times, that we are interested in total 36 outcomes, right, where x1 represents the outcome on the first die and x2 on the second die, right? So this is the one approach, right? Second approach is the which we have discussed actually, okay. I mean, this approach was very general approach. Now we will proceed with the our standard. So this is maximum of x1 comma x2 less or equal to 3, right? And we have seen this, I can write x1 is less or equal to 3 and x2 is less or equal to 3, yes or no? Correct?
Yes, sir.
And these two are independent, so I can write x1 is less or equal to 3 into probability that x2 is less or equal to 3. Would you agree with me?
Yes.
Now, when x1 is less or equal to 3, that means what? This part is what? Probability that x1 is 1 or x2 is, sorry, x1 is 2 and x1 is 3. Basically, I shouldn't write like this. Everyone is getting my point? See, probability
Yes, sir.
x1 is less or equal to 3 means what? Probability x1 is 1 plus probability x1 is 2 plus probability x1 is 3. Yes or no?
Yes.
Right? And what is the probability that x1 will take value 1? When that means you are throwing a die that is 1 by 6.
Yes.
See, x1 is what? Outcome on the first die, right? Then x1 will take, x1 can take value 1, 2, 3, 4, 5 up to 6. So for each value, probability will be equal. Yes or no?
Yes.
So this will become 3 by 6, which is half, right? If now to calculate this value, probability x2 is less or equal to 3, that means what? X2 can take value 1 plus probability x2 can take value 2 plus probability x2 can take value 3, right? Again 1 by 6 plus 1 by 6 plus 1 by 6, which is 3 by 6, which is 1 by 2. Yes or no? So you can see this value is 1 by 2, this value is 1 by 2, which is 1 by 4, which is answer. So you can cross check with the first approach. In the first one, we got 1 by 4. In the second one, again we got 1 by 4. Is this clear?
Yes.
Yes,
Yes.
sir.
Right? Now next part is, if now okay, answer is given shown to you, but how to proceed? If probability z equal to 4 is a by 36, then what is the value of a? So question is, second part is, probability that z equal to 4 is a by 36, then what is the value of a? Okay, at the first time, what should be your approach? I mean, what will be your thought on this?
Sir, we can consider like combination less than, if we consider like
Okay,
x1.
basically z equal to 4 means what? We have to think maximum of x1 and x2 should be 4.
Yeah.
Yes.
Yes or no?
Yes.
Right? So yeah, someone was speaking, but your voice is too low. I can't hear. So here probability, yeah, z equal to 4 means what? Probability that maximum of x1 comma x2 should be equal to 4. Yes or no?
Yes.
Right?
Yes.
So we have to think all those cases when maximum of x1 and x2 should be equal to 4.
So,
Right?
sir, we can do this like we fix x1 as 4 and then count what x2 can be. So there are 6 cases. And
6
then
cases.
fix x2 as 4 and then x1 as 6 cases. So 12 cases.
No, then
No,
you can't.
I
One
think
second. You
5 and
need
6
to
would be
take
more.
care of one second. You have to take care of this also. Maximum should be 4 only. You can't say 5 comma 4 equal to 4, right? Are you
Yes.
getting?
Oh yes, yes. So x1 will be then what? 1, 2, 3.
8 cases
Okay,
total.
okay. Let's do like this. 4 1, 4 2, 4 3. So far so good.
And 4 4.
Yes.
4 4.
One time.
Right? One time, right? Now reverse order. 1 4, 2 4, 3 4. I think that's all.
Yes.
Right? These are the possible cases when maximum of these two will be 4. you can't take 5 4, right? Because maximum of
Yes,
5
yes,
4
that-
is not 4, is 5, right? So it's a total 7 cases, right? That means what? This is the 7 by 36. Yes or no?
Right.
So value of A will be
7.
okay. So now is this clear? So you can see the same concept we have discussed, just a small manipulation, and you have to do the questions, right?
Sir, here both x1 and x2 belongs to same distribution, so we can write directly 7 by 36. But if
Correct.
they are from different distribution, then we need to multiply each,
Multiply, yeah. Correct.
take each probability, right?
Yeah, that's what we did here, right? That's what
Yes,
we
yes,
did.
yes,
Okay.
yes, yes, sir. Yes, sir. Okay.
Got it? That's why I explained that concept. So
Can you repeat what you just said?
no, actually, see me, if you have been given two different distribution, let's say x1 is something, x2 is something, right? But one more thing, it should be independent, right? Because we are considering the independent case here, okay? Then if I'm question is, let's say z is maximum of x1 comma x2 less or equal to 1. So maximum of x1 comma x2 less or equal to 1, then I can write x1 is less or equal to 1 and x2 is less or equal to 1, right? Since these two are independent, x1 is less or equal to 1, x2 is less or equal to 1. So whatever the information about x1 is there, whatever the information about x2 is there, you can simply multiply the probability. Got it? Yeah.
So, sir,
Uh-huh.
can I just take to that page once? Just once.
Which page? This one?
This one, yes. So up to this first second equals, just the step above this, this step. So this step, this will work for anything. Then the next two step, the second step works for independence because it is independent, and then the third works because of same distribution.
Identical.
Identical distribution.
If identical is not there, then you have to calculate the probability here.
Yes. Now, depending upon the information, we can stop either in the third step or fourth step. But the first two steps are the general.
Correct.
Okay.
Okay. Let's do the function. This question number 9. Okay. Then we will stop and maybe we can discuss this PDF in tomorrow's session, because I think you have math session, right?
Yes, sir.
Okay. Let's try to do this.
Excuse me, but tomorrow is revision for week 3 and 4.
No worries. We will tomorrow. What we will do? We will simply discuss the questions. Okay. I think just few days ago we have discussed the concept of week 4. Okay. So along with question, we will cover the concepts. Okay. Okay. Anyway, we have covered the content. So what I will do, I will share the PDF with all of you. You can try on your own. Okay.
That's better, sir.
Okay. Okay, let's try to do this question. So x and y is given to you minus it's IID uniform minus 101. Okay, let me write here because I will solve the question. So question number 9 says x and y. This is IID uniform minus 1 0 and 1. If this is minus 101 uniform, then what will the probability for x?
1 by 3.
1 by
3.
So this is the question, and we have to identify the PMF of Z, right? So one of this value will be correct. So what I told you, how to proceed, make the table. It might be long, but you will get the correct answer with the less probability of making mistakes. Okay. So what is the possible values will be? Minus 1, minus 1, minus 1, 0, minus 1, 1, right? Then 0, minus 1, 0, 0, 0, 1, 1, minus 1, 1, 0, 1 and 1. Now, what is the function? Z equal to modulus of x plus y. So what will be the mod of x plus y here? 2. Right? Here. Because if you add minus 1, that will give you minus 2. Modulus of minus 2 will give you the 2. Right? Here, 1.
1.
Here, 0. Yes or no? Minus 1 plus 1 is 0, right? Here, 1, 0. 0 plus 1 is 1. 1 minus 1 will be 0. Mod of 0 will be 0. 1, 0 is 1, 2. So far, so good?
Yes, sir.
Yes.
Now, what will the probabilities for this part? 1 by 3 into 1 by 3, which is 1 by 9. Basically 1 by 9 for all, because this is uniform. 1 by 3 will be the probability, right, for each value. Yes or no?
Yes.
Are you getting my
Yes,
point?
sir.
Yes, sir.
See, 1 by 9, 1 by 9, how simple this is, right? 1 by 9, 1 by 9, 1 by 9. What is the possible value Z can take here?
0, 1,
0,
2.
1, and
0,
2,
1,
right?
2.
Correct. Then you have to find the PMF. So what? Okay, you will tell me what is the probability for 0. We have to add all this probability, right?
3 by 9.
Basically, we have to add this probability plus
3
this
by 9.
probability plus this. That is 3 by 9,
Yes.
Yes, sir.
which is 1 by 3. For 1,
4 by 9.
4 by 9.
Oh, sorry. Yeah.
1 this part, 2, 3, 4, right? So 4 by 9 for 2, 1 by 9
2 by 9.
plus 2
2
by
by
9.
9.
So you can see this is the 42639. This is total probability is 1, right? This is valid PMF, right? Someone asked whether it's valid or not. Is this clear? So now
Yes,
you
sir.
can see
Yes.
1 by 3, 4 by 9, 2 by 9. That means option B is correct. See, you will get the 3
Correct,
marks.
sir.
This question was 3 marks. Okay. So you should be clear with the concept. So good approach is start with this table. The advantage of making this kind of table, you will not miss any combination. Are you? This is okay. So
Yes,
B
sir.
part is x equal to 0, probability of x equal to 0 given that z equal to 1. So we will do probability of x equal to 0 given that z equal to 1. So this means what? Probability that x equal to 0, z equal to 1 divided by probability of z equal to 1. This is the formula. Okay. Z equal to 1 you can find from here. Right? Yes or no? The key
Yes, sir.
thing, you have to identify the numerator part, right? So numerator part is what? You have to think a bit. That will not give you. Okay. So numerator part is what? Z is what? This means see, x equal to 0, modulus of x plus y should be equal to 1. Yes or no?
Yes, sir.
Yes,
Right?
sir.
And it is given that x equal to 0 when y is
Y.
equal to 1. Right?
One.
This means what? So in the numerator part, you have been given x equal to 0. Basically, we have to see the common part, right? This means for x equal to 0, when modulus of these two is equal to 1, so x is 0, y is equal to, basically when addition is 1, in this case, and these two are cases only, right? Are you getting my point?
Yes,
Right.
sir.
Yes, no?
Yes, sir.
You can see this part,
Yes,
right?
sir.
When x is 0 and addition of these two is equal to 1. X is 0 and addition of these two is equal to 1. Yes or no?
Yes, sir.
Yes, sir.
Right?
Yes,
So
sir.
it will be 2 by 9. Numerator will be 2 by 9 or not?
Yes, sir.
Yes, sir.
Right? Basically, this means probability x is 0, and when this happen actually, y equal to -1, or probability x equal to 0, y equal to 1. Only in these two cases, this will be true. Yes or no?
Yes.
So
Yes, sir.
2 by 9 divided by 4 by 9, probability of z equal to 1, I can take from here only. So it will be 9 will get cancelled
1
out,
by
2 by 4, which is 1 by 2, which is 0.5. So you can see 0.5 is the correct answer. Okay.
Okay, sir.
Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes.
So
Yes.
would you like to discuss the question in tomorrow's session, or should I upload on the portal? It will be uploaded by tomorrow morning only, because I have to share with the team. They will upload it by tomorrow.
Sir, tomorrow are you going to do revision of week 3 and 4, or are you going to do questions, sir?
Okay, so there is two. I will go with the same approach. Means I will take the collection of questions which has been already asked, some previous terms. Okay, so what I will do, I will directly discuss the question, and along with the question, we will discuss the concepts. Okay,
Oh, okay, sir.
right?
Sir, can you
Sir,
share
sir.
the PDF?
Sir, is it
The
possible
question?
if you Sir, is it possible if you just cover the concepts and just give the questions as PYQs for solving for
Anything fine. So what we will do, we have covered the week 1 and 2 concept today, right? In the
Yes.
first 1 hour, we will cover the concepts of week 3 and 4, and the remaining time we will try to discuss the questions. And After that, I will share the PDF and you can try on your own. Anyway, answer will be with you. You have to just apply the concept whatever we have discussed. All right.
Yes, sir.
Oh,
Sir, can you share the link of the PDF, sir?
PDF you can find under the supplementary content live session notes, but
Sir, right now, sir, you have already opened it, sir. Can you just copy the link from there and paste it over there in comment section?
okay, for now I can share. I'm not sure whether it will be shared or not. Okay, let me
Also,
check.
Directly uploaded the clips folder in Google.
Or
sir, is there any spreadsheet for like stats 2 as well?
spreadsheet for what?
Like all the live session and recorded videos and these PDFs.
You can check the calendar, right? I mean playlist, right?
Yeah, but like for maths 2, they made one and added everything in that.
Okay, we will see. I'm not able to paste here. I don't know why. I'm not able to share in the chat.
Yeah, like there's no option for the PDF to send here in
Correct,
Gmail.
correct. Okay, anyway, by tomorrow we will upload. Do not worry, okay?
Sir, in which section will it be uploaded,
Under
sir?
supplementary content, you can find live session notes. There you can find this PDF, okay?
Oh, yes.
Oh,
Thank you, sir.
okay, all right. Then
Thank you,
we
sir.
will start the content of week 3 and week 4 tomorrow. Hope you got the idea of week 1 and 2 today, okay?
Yes.
Okay.
Thank you, sir.
Okay.
Thank you, sir.
Thank you. All
Thank you.
right. Thank you.
Good night, sir.
Good night.
Thank you,
Good
sir.
night. Bye.
Thank you, sir.
Thank you.